So, second section of chapter 3, we're going to be talking about adding, subtracting, and multiplying polynomials. So this is an example I want you to write on the front page of your notes that we're going to do together. So we have 6x to the third plus 4x plus x squared minus 7 plus 2x to the third minus 8x squared plus 3. Go ahead and write that example down. Okay. Think back to when we did complex numbers with operations, right? With the i's. Okay, we treated those as x's, right? Okay, now we have actual x's. What is the operation that's happening? Adding. Does adding change the value of anything in this expression?
No.
No. So what can we do with those parentheses right off the bat?
Find what's... Get rid of them.
Right, I can get rid of the parentheses. I'm going to take that step first. We have 6x to the third plus 4x plus x squared minus 7. Again, I'm not changing anything. Everything is keeping its same value and the same sign that it had in front. So I just took those parentheses away. Okay, here it just wants us to simplify. How do I simplify this? It is combining like terms. One thing that we have to be careful with, though, is we have to write our answer in standard form. Okay, so there's kind of an order that we have to combine like terms. So thinking here, what is my degree? What is the highest exponent?
3.
It is 3. Okay, so 6x to the third, what's its like term? 2x to the third. So if I combine those, I get 8x to the third. Again, I like to cross things out once I've used them, so I know I'm done with those. Okay, what do I want to combine next?
The squares.
Yep. X squared minus 8x squared, which is,
9x squared.
careful.
Negative 9.
Yeah, negative 7x squared. Okay. What's my next term going to be?
4x and, wait. No, 4x just stays the same.
Right. Is there a like term with 4x?
No.
No, so that one's just going to stay the same. And then what are the last two things I can combine here?
Negative 7 and 3.
Negative 7 plus 3 is?
Negative 4.
Negative 4. Okay. You know you're done when you can't simplify anymore and your answer is written in standard form. Next one we're going to do together, I want you to write this one down. We're going to do 3x squared y squared plus 2xy squared plus 6x squared minus 2x squared y squared plus 3xy squared minus 2x squared. I'll give you time to go ahead and write that down. All right, what operation's happening in this one?
Subtraction.
We do have subtraction here. Can we just act like it's addition and treat it like addition?
No.
No, you have to bring subtraction.
Yeah, that subtraction, remember we treat it as a negative 1. What does it do to all of these signs here? It changes them. Does the front change?
No.
Or that first section? No, so I'm going to keep the first the same. And again, treat this as a negative 1. What does that 2x squared y squared turn into? Negative 2x squared y squared. What's next? Minus 3x y squared. And then plus 2x squared. Good. Okay. How do you think we go from here?
Combine like terms.
It is going to be combining like terms. Notice that, for example, on this first one, we have two different variables that we have to match up. Okay, since we have two variables here, you do not have to worry about standard form because that can get a little confusing here. Okay, so let's just start left to right. Is there a like term with 3x squared y squared?
Negative 2.
Yeah, negative 2x squared y squared. Okay, they're like terms because these here that's attached to the coefficient perfectly match. Okay, so what's 3x squared y squared minus 2x squared y squared? Yep, 1x squared y squared. Okay, again, we're going to work left to right. What about 2xy squared? Does that have a like term? Where? Yep. What do I get when I combine those?
Negative.
Yeah, it is a negative 1xy squared. Okay, and then can I combine 6x squared and 2x squared?
Yes.
Yes. What do I get when I combine those?
8x.
8x squared. How do you know if you're done again? Can't combine anymore. Yep. So you're done when you can't combine any more like terms. All right, example 1A, what operation's happening?
Addition.
It is addition. Okay, so what can I do with those parentheses? Yep, get rid of them. So we have 4a squared minus 6a to the third minus 3a squared plus a plus 1. Again, does anything change with this side? No, it all stays the same. Okay, how can I simplify this from here? Yeah, we want to combine like terms. Specifically, how do we want to combine like terms?
The ones with the exponents, the same exponents.
Yep, we want standard form. So what's my highest degree? Oh, it sure does. Thank you. Just this one, right?
Yeah.
It says 4a to the fourth. Okay, so sorry about that. Now, what's your highest degree?
4.
There we go. Does it have a like term?
No.
No. Okay, so we're just going to keep that one the same. Okay, what else?
You can do negative 6a to the third and 5a to the third.
Yep, what do I get when I combine those?
Negative 1a.
Negative 1a to the third. Okay, what about negative 3a squared?
Yeah, it's negative 7a.
Plus 7a squared is 4a squared. And then we have a plus 2a.
2a.
Careful. That would be if we close to multiplying, but technically this is a 1a. So what's 1a plus 2a? 3a, there we go. And then we have 1 minus 2,
Which is minus 1.
which is negative 1. Yep. Again, you're done when you are in standard form and you have no more terms to combine. Are there any questions on that problem there? Okay. How is part B different?
Subtraction.
It has subtraction this time. How does that change the process?
Between the signs on the right side.
Yeah, we gotta distribute that negative 1, which changes the signs to the right side. Did anything happen with the left set? Nope, so this one stays the same. Okay, tell me what to write next.
Negative 3a squared b squared. Positive 9a squared b. Negative 7ab squared.
Good. Again, 3 changed to negative 3, negative 9 changed to positive 9, and positive 7 turned to negative 7 because of that subtraction sign. What do we do from here?
Combine the terms.
Combining like terms. Does this one standard form matter? No, why not?
Because there's 2 exponents.
There's multiple different variables here to look at. So we're going to work left to right. What is a like term to 2a squared b squared?
Negative 3a squared b squared.
Yep, so that's going to give us negative 1a squared b squared. What about ab squared?
Negative 7.
Yep, so what's 3ab squared minus 7ab squared?
Negative 4a squared b. Negative 4ab squared.
Yep. And then we have negative 5a squared b plus 9a squared b. 4a squared b. Yep. And again, you know you're done with those when you can't combine any more like terms. All right, moving on to multiplication, I want you to go ahead and find a spot to write this down. Go 2m plus 5 times 3m squared minus 4m plus 2. Okay, what operation's happening this time? Multiplication, right? Because they are right next to each other, no operation is splitting those apart. How do we multiply?
FOIL.
It's the FOIL method, or distributing, right? So I'm going to start with that 2m. I'm going to take 2m times 3m squared. Now, let's talk about this for a second. What is 2 times 3? 6. Let's think about the m's for a second. I'm multiplying m, 1m, right? Times 2 more m's. How many total does that give me? It gives me 3, right? So when you're multiplying powers of the same base, what I mean by that is they have the same base below the exponent, you are going to add those two exponents together. Okay? So multiplying powers of the same base, you are adding those exponents. Okay? So now I'm going to multiply 2m times negative 4m. So what's 2 times negative 4?
Negative 8.
Negative 8. What's m times m? Yep, putting them together, you get m squared. And then last one here, we have 2m plus 2
Plus 4.
plus 4m. Where do I move on to next?
The 5.
I got to do the same thing with 5, right? So I'm going to take 5 times 3m squared
15.
15m squared. And then 5 times negative 4m.
Isn't it supposed to be 3? Oh, wait, no. Yeah, 15 doesn't have one. Never mind.
We good?
20m.
It is negative 20m. And then, no, I'm running out of room here. What's 5 times 2?
10.
10. Are we done multiplying?
No, because when you combine 8 and 15.
Well, correct, but we're done multiplying, right?
Oh, yeah.
Yep, done multiplying. Now, are we done with the problem?
No.
No, we got to do what?
Combine like terms.
Combine like terms, specifically how?
Adding.
The exponents, like negative 8m squared and 15m squared.
Right, and we have to write it in what form?
So,
Standard form. So what's my highest degree?
6m.
Yeah, to the third. 6m to the third. What can I combine with negative 8m squared?
15m squared.
Yep, that will give us 7m squared. And then what's 4m minus 20m?
16m.
Negative 16m. And then what do I do with this constant plus 10? Yep. Again, you know you're done when you have no more like terms to combine and you are in standard form. Questions on multiplying? Okay, we're going to do one more example together. Actually, no. Go ahead and flip to your example 2. There are fractions in there, so I want to change these. Okay, so example 2, part A, you're going to have 6n squared minus 2 times n squared plus n plus 3. Go ahead and start on part A. And then I'm going to change part B also. All right, again, on example 2, A and B, what operation's happening? Multiplication. So remember, it's the FOIL and distribute method. Okay, so we're going to take 6n squared times n squared. What do we get? 6n to the fourth. Remember, what are we doing with these exponents here? We're adding them together. Yep. So then take 6n squared times n, which is, careful, 6n to the third. Yep, because remember the exponent on this one is 1, so we want to add those together. And then lastly, take 6n squared times 3. 18n squared. What do I want to move on to next? The negative 2. What's negative 2 times n squared? Negative 2n squared. Negative 2 times n? Negative 2n. And then lastly, negative 2 times 3. Negative 6. Are there any questions up until this point? Okay, what do we do next here? Yep. Standard form, combining like terms. What's our highest exponent? 4. So that's going to be our first term, and it has no like terms. Does 6n to the third have a like term?
No.
Nope. What about 18n squared?
Yes, negative 2.
Minus 2n squared to get 16n squared. And then, which one of these is written first? Yep, negative 2n minus 6. Okay, how is part B a little bit different?
There's y, there's y squared.
Right, we have two different variables that we're working with, okay? We still keep them separate from each other, okay? So let's walk through this one. We take the same process with multiplying. We take 3x times 4x squared. So what's 3 times 4? 12. What's x times x squared? X to the third. Okay. Again, take this one at a time. 3 times technically a negative 1 there. Negative 3. We take x times x, which is x squared. And then, yeah, this y that's here, we're just going to tag it at the end. And then do the same thing here. What's 3x times 2y squared? 6x y squared. Good. What do I do next?
You do the same thing with 2y.
Yeah, I do the same thing with 2y. So what's 2y times 4x squared? Again, do it all separately. What's 2 times 4? 8. What do I do with this x squared? Keep it. What do I do with the y? Keep it. Yep. So now we do 2y times negative xy. What's 2 times technically that negative 1?
-6. Wait, what?
Negative 2, right? And then what do I do with this x? Keep it. And then what's y times y? Y squared. Yep. Again, do everything one at a time. And then lastly, what's 2y times 2y squared? 4y cubed, or 2 to the third. Yep. Again, take everything slow and one at a time. What do I do from here then?
Combine factors.
Yeah, combine like terms. Can I write this one in standard form?
No.
There's 2 variables, right? So does it make it kind of hard to do that? Yes. So we're just going to work left to right here. What can I combine with 12x to the third? Anything?
No.
Nope. So that's just going to stay. What about x squared y?
Yes.
Right here, right? So what's negative 3 plus 8?
5. Positive 5.
Yep. X squared y. And then what about these 2 here? What do we get if we combine those?
Positive 4.
Yep. And then what do I do with this?
Put it in. Just
Yep.
keep it.
Tag it on at the end there. Then we are done. Okay. Any questions about multiplying polynomials? Again, when you're multiplying exponents, you're adding those together, okay, with the same variable.